In today's networks, we're using many different kinds of devices. We might have a laptop computer, a desktop workstation. We may be using a voice over IP phone on our desk. And of course, we have a number of different mobile devices that we might use. On these devices, we're using a number of different applications. We might have a mission-critical application that's used to perform the major functions of our particular job. We might have a voice-over IP application that we're using. We might perform streaming video or streaming audio, and all of these applications have different network requirements. Voice communication requires real-time data flows. If you're watching streaming video, there's usually a buffer associated with that on-demand video display. And if you're using a database application, there's usually an interactive input and you're expecting an output within a certain amount of time. This means that you might want to prioritize the type of traffic on your network. For example, you may want to have voice over IP traffic have a priority over someone who may be watching YouTube videos or transferring files. One way to provide this prioritization is through packet shaping. You might also hear this referred to as traffic shaping. This is where we can apply certain bandwidth usages or data rates to a particular type of application. This means that we might be able to set certain applications to have a higher priority on the network than other applications. And of course, there are many different ways to implement this. This may be provided in a firewall, in a router, or inside of a switch. If we're setting these priorities of different applications and prioritizing by the amount of bandwidth or traffic rates that an application uses, we often refer to this as quality of service. This is a very broad description that allows us to define the process of controlling these traffic flows across the network. There are many different ways to implement quality of service across many different topologies, but there are certain standards that you'll often see used on most people's networks. One of those standards is the class of service, or COS, that you can configure on an OSI Layer 2 network. This is a type of prioritization that is performed inside the Ethernet frame header in an 802.1q trunk. So this is very specific to communication between switches. This is something that we would commonly then perform inside of our own intranet because we don't commonly have a trunk connection to our internet service provider. If quality of service at Layer 2 inside of a trunk is a bit confining, you may want to implement Diffserv. This is differentiated services, and this is a type of QoS that you're able to implement at OSI Layer 3. With Diffserv, we're modifying quality of service bits within the IPv4 header. These bits are usually set outside of the application. So you would usually have a device on the network that would recognize the application and then set the proper bits inside of the header. Normally, this would be done inside of routers or inside of firewalls that have this Diffserv capability. These values that we apply inside of this IP header are differentiated services code points, or DSCP values. These are set inside of the IP header in a very specific field called the DS, or differentiated services field. In some environments, you may take advantage of both class of service and Diffserv to be able to set the proper priorities for the applications and devices inside of your network.